Okay, so let's start with the first project. Select new project. In this window, you must put each project in the devoted directory, separate directory. Don't mix two projects in the same directory. So instead of parity, I'd like to have a first. It is the directory. I will name the same the project. Okay, first. It is legal. First is the directory, and below the directory you've got the project, which is named. Many files will be created for the project. And from the design enter type, you can of course draw the schematics as we did during the digital systems. Yes, you simply draw gates, etc. You can do it here also as well, but for this course, you rather should forget about this. Okay, rather we concentrate on VHDL as only for this language without drawing anything. But you can, if you like, to draw the diagram or if you know the diagram from scratch. Okay, we now select the IC, the programmable device, the hardware, which is available on the boards. There are 4 chips from family Mach 4A5, and the concrete one is Mach 64/32. 64/32. The speed is now 10 nanoseconds, which means that from the change on the input and the appropriate change on the output, it takes 10 nanoseconds maximum, okay, or less. 10 is the maximum. You have a guarantee that if you change something on the input, the reaction will take at a maximum 10 nanoseconds. It's a quite fast device. And finalize zakończ in Polish version, of course. If you have Windows in English, of course, you will get English messages. Okay, so you've got the first and empty, almost empty. You've got a model of this device, a software model of hardware. Okay. So to start with, you must add at least one source code, source file, source new, and then VHDL module as well. Okay, VHDL module. We will be interested only with these 2 options: VHDL module for design and VHDL test bench for testing this design. Okay, so testing, you will prepare a testing file or test file in the same language, VHDL. Okay, VHDL design and VHDL tests. Okay. So let's start with module. Now, let's say that we'll be doing the gate, entity gate, a single gate. Let's start with a single gate. Architecture. Architecture is the name of, you get the concrete design can be named. You can design the particular device in many ways. Okay, and each way can have each name. Architecture is the name of the architecture, is the name of the solution. You can have many solutions of the same problem. Okay, you can design even AND gate can be designed in many ways. Okay, so simple. Okay, that's all. What you have, it is automatically generated libraries which are included or will be included in the design. Okay, it is counterpart of including C language. Include this library, this library, this library. Okay. This comes from IEEE libraries. Then you've got the entity. Entity is the block diagram description. If you draw, I will show you how to draw. I must open the appropriate PDF with empty slides. Okay, and drawings. Where are drawings? Yes, that's it. Okay, so review. Okay. if you start, as you remember, if we started in digital systems to design something, I draw the block diagram. Yes, there's a block diagram where you had inputs. Inputs can be named A, B, C, and the output Y, Z, let's say. Okay, Y, Z. So these names, these and these are the part of entity. You simply name the inputs and the outputs, all the inputs and all the outputs of your design, entity. Okay, so let's return to our design file. So for gate, you simply start with port. They are ports. The pins, the pins outside inputs and outputs are called ports. Okay, and inside you put the name of the inputs. Let's suppose they are A and B for 2 input NAND, for 2 input XOR, for a gate of 2 inputs. So to denote that they are inputs, you simply put it in, and then the type, because it is port. Port, it is a signal, it is a new. Ports are signals, because there's a physical pins on these ICs. So the type of the signal, the physical type, electronic one, is STD logic, standard for the digital binary systems. Okay, this STD logic, digital ICs, all the signals are of type STD logic, and we'll be doing this, but with exceptions. I will show you the exception later on. And Y is the output, it is out simply, and also STD logic. And be aware that first parenthesis and then semicolon. Okay, not the opposite. That's all as far as block diagram of the gate is concerned. We don't know what's the operation of it, but we know the interface lines. 2 inputs named A, B, and 1 output named Y. Okay, so begin here. Description. Description is very simple, but be aware that the assignment operator is like this: lower or equal to, lower of equal to. In Pascal, you have something like this. In C, only this. Okay, it is an assignment. The left-hand side will assign the value of the right-hand side after executing of this line. Okay, this is the interpretation. So this is something like this: Y is equal A, and what gate you want to have, what type? If you would like to have AND, you simply put AND keyword. If you would like to have NAND, you simply change it into NAND. Very simple idea, NAND B. That's all. We have designed a NAND gate. Okay, a single NAND gate. Okay, how to verify if it's correct? If it operates correctly. Oh, we are sure because we have only one line, and the name NAND stands between A and B. So, but if you have a more complex design or more complex description, the good idea is to start with this file, test bench. Okay, not with the designing process, but think first about how to test it, to verify if it's correct. Okay, this is the more important part, to verify if it's correct, how to prepare the testing file, test file, before you start even designing this. Okay, so source new again, then VHD test bench is the name of the test file, is the type of the test file. Here we we are choosing the name of the device, real device, because we'll be testing a real hardware by using software, but the model will be very exact. The file name, the standard way is the same as the name of the design main Right? It's a gate, perhaps I should name it gate, and test bench TB. Okay, the standard name. At the end of the name, you put underscore TB. Okay, and you've got it. In order to start with, we will generate automatically the framework or the template. Yes, there is a template of this file here generated using option VHDL testbench template. You've got this option, simply double click. You will have this file generated, but of course the testing instructions will be empty. Okay, you must put here. What's the up? You've got the library as well. Then an entity. Entity is empty. It is a standard. Name is also standard testbench. You can use any name here. You must repeat the same name here. Architecture is the next part of this, and component signal. These are signals from outside world. This is this component to be tested. Its name is a gate. But these are signals which come, they have the same name because it is generated in such a way. And then we connect the signals from outside world to the signals of the gate. A is connected to A, B to B, and Y to Y. The name can be different. Right? These names, A, B, Y, can be C, D, E, let's say. And you must repeat C, D, E here. Okay. But the standard way is to name them the same. What we do? We do the same. We simply put the values. Instead of equations, you've got A equal to 0. Okay, it is command for the simulator to put 0 on input A, to put 0 on input B, let's say. Okay, and then you'd like to change another one, another combination. There are 4 combinations. You can simply use copy-paste method. I make a lot of errors if I use copy-paste. Okay, A00, 01, 10, and 11. Exhaustive test. Okay, all the combinations will be put on the input. Okay, but you must wait here. You must wait here after each combination. You must stop the simulator to get the result on the output. It will take 10 nanoseconds, as I said, the speed. So you must put here the wait statement. Wait for at least 10, but for sure to have a stable output, wait for 20 nanoseconds. Okay, so simulator put zeros, wait to get the result on the output, then put 01, wait, 10, wait, 11, wait. Okay, so I also copied this Control C and put it here and put it here and wait. The last wait will wait forever. The simulator stops by itself. Okay, the simulation will stop, but here you have a wait without any for. We wait forever. Okay, so let's try it. If you finish the design, the first step is to compilation. You must wait because the libraries are included and compiled as well. That's completed successfully, means everything is right. Then you must fit design to your hardware very quickly and then test it in the timing simulations. You will get the waveforms. Okay, oh, you don't have it because I made error. We must localize keyword and expected. And where is end? expected were untitled. We will see in a moment.